Today I am going to talk about load calculation for G+1 building. First, let us discuss about the load transfer mechanism. How the load transfer happens in the building. The load which is coming on the slab will transfer to the beam, and from the beam it transfer to the column, and from column it transfer to the footing, and finally it goes to the ground. This is the simple load transfer mechanism of a building. Here we have the architectural drawings and structural framing plan. The first and basic step before starting the design of a building is to make a frame of a structure according to the architectural plan. Here we have the ground floor roof framing plan and first floor roof framing plan. Now let us discuss how the loads are getting transferred into each of the structural elements. In this framing plan, we have all the slabs are two-way slabs. If you want to know more detail about one-way slab and two-way slab and their load transfer mechanism, please refer my playlist. I have already uploaded one detailed video about one-way slab and two-way slab. Here let me explain quickly about the load transfer mechanism for this two-way slab. This triangle portion of the load will transfer to beam 5, and this trapezoidal portion of the load will transfer to beam 8, and this triangle portion of the load will transfer to beam 7, and this trapezoidal portion of the load will transfer to beam 10. Okay, along with that we have one cantilever slab. This cantilever slab load will transfer to beam 6. Rest all slabs are two-way slabs only. The load transfer will happen as I told here for this slab. Now let me explain for simple slab how the load will transfer from beam to column. So here is also a two-way slab. This portion of the load will goes to beam 1. From beam 1, half of the load will goes to this column and half of the load will goes to this column. But here we have a frame. If you take this beam 1, it is a continuous beam. Since it is a frame action, we cannot divide the column load as I told here for this simple beam. So we have to analyze the structure, analyze the frame by using the software, and we have to find out the column loads. Till now we have discussed about load transfer mechanism of each structural elements. Now let us discuss what are all the loads coming on the structure. In this video, we are going to discuss about only gravity loads, not lateral loads. So, gravity loads are generally classified as dead load and live load. Dead loads are static loads and it includes the self weight of the structural elements, permanent partitions and immovable fixtures. IS 875 is the code of practice for design load. Part 1 is specifically for dead loads. Here we discuss what are all the loads coming under the dead load. Self-weight, floor finish load, partition wall load. For example, consider this slab. This is the partition wall which is coming and resting on this slab. So that will create some stresses on the slab. So while calculating the loads on the slab, we have to consider this partition wall load, main wall load, parapet wall load, sunk slab load. This is the sunk slab. While calculating this slab load, we have to consider this sunk slab load also and staircase load. Let us discuss in detail about how to calculate each and every loads which is coming on the structure. The first one is the self weight. How do we calculate the self weight of the slab? Slab thickness multiplied by unit weight of RCC. Okay, so here is the slab. The thickness mentioned here is 125 mm. So thickness of the slab is 125 mm and 0.125 multiplied by 25 kilonewton per meter cube is the unit weight of RCC. You can refer from IS 875 part 1. So that is for unit weight of all the materials. So by solving this we get 3.125 kilonewton per meter square. So this much is the self weight of this slab. Next one is the self weight of the beam. How do we calculate the self weight of the beam? that is beam width multiplied by beam depth multiplied by unit weight of RCC. So here the beam size is 200 by 450 mm. So if we apply this, we get 2.25 kilonewton per meter. So this is the self weight of the beam. The next one is the self weight of column. Self weight of column can be calculated by multiplying the unit weight with volume of the column. Column size is 200 by 450 by 3000. 200 is the width of the column, 450 is the depth of the column, and 3000 is the length of the column. Length means that is the floor height. So by solving this we get 6.75 kilonewton. This is the self weight of the column. Second one is the floor finish load. Consider the thickness of floor finish as 50 mm. Unit weight of cement mortar is 20 kilonewton per meter cube, which we use for finishing the floor. Refer IS 875 part 1 for unit weight of materials. By solving this we get 1 kilonewton per meter square as a floor finish load. This load has to be applied on the entire area of the slab. Next one is the partition wall load. For example, consider the partition wall is coming on the beam. So that load has to be transferred to the beam. Here thickness of partition wall is 100 mm, height of the wall is 3000 mm, unit weight of brick masonry is 20 kilonewton per meter cube. You can refer IS 875 part 1. By solving this we get 6 kilonewton per meter on the beam. So this load has to be applied as a UDL on this particular beam as a partition wall load. Let us discuss how to calculate the load if the partition wall is coming on the slab. Here is the partition wall. This is coming on the slab. This will create some stresses on the slab. So while calculating the load, we have to consider this partition wall load also. We have to consider 1 kilonewton per meter squared as a partition wall load on this entire slab. Fourth one is the main wall load. The thickness of the main wall is 200 mm. The mostly column width and the thickness of the wall should be the same. The height of the wall is 3000 mm, that is the floor height. Unit weight of brick masonry is 20 kilonewton per meter cube. Sorry. So by solving this we get 12 kilonewton per meter. So this 12 kilonewton per meter has to be applied on this beam since the wall is resting on this beam as a UDL. So this is the way we have to calculate the main wall load which is coming on the beam. Next one is the parapet wall load. Thickness of the parapet wall is 200 mm. Height of the parapet wall is 1200 mm. Since we are taking G+1 building, on the first floor there will be a parapet wall. Okay, so that height of the parapet wall is 1200 mm. Unit weight of brick masonry is 20 kilonewton per meter cube. So by solving this we get 4.8 kilonewton per meter. So this load has to be applied on the entire beam on the first floor roof as a UDL. So this is how we have to calculate the parapet wall load, and we have to apply as a UDL on the beam where the parapet wall is resting. Next one is the sunk slab load. Sunken slabs are common in all the buildings where we have toilets, bathrooms, utility and porticos. Here the thickness of the sunk slab is 250 mm. How do we calculate the sunk slab load? That is the sunken slab thickness multiplied by unit weight of the filling material. Okay, so here we are considering the filling material as cinder. Unit weight of the cinder filling is 8 kilonewton per meter cube. So by solving this we get 2 kilonewton per meter squared as sunk slab load. So this sunk load has to be applied on this particular slab. So what are all the loads will come on this slab? So this slab self weight of this particular slab, and along with that we have to apply the sunken slab load. The next one is the staircase load. Here the thickness of the base slab is 150 mm, riser is 150 mm, tread is 300 mm. So we have to calculate the loads on going and loads on landing. This is the landing and this is the going. So here how we are transferring the load, we have to consider this as a one-way slab in the longitudinal direction. So half of the load will go to this beam and half of the load will go to this roof beam. So consider at mid-landing level. So this is the mid-landing beam. So half of this load will go to this mid-landing beam and half of the load will go to this roof beam. Okay, so how we have to calculate the self weight of the waste slab. So first we have to calculate the loads on going. So for that we need to calculate the self weight of waste slab. So that is thickness into unit weight of RCC multiplied by the um, square root of R square plus T square divided by T. This R is a riser, T is the tread. So by solving this we get 4.19 kilonewton per meter squared as a self weight of waste slab. Next, self weight of the steps. So we have the thickness of riser as 150 mm. Unit weight of RCC is 25 multiplied by half of the riser thickness. So the self weight of step is 1.875 kilonewton per meter square. Floor finish load is 1 kilonewton per meter square. Live load as per IS 875 part 2 is 3 kilonewton per meter square. So total load ongoing is 10.06 kilonewton per meter square. Next, we have to calculate the loads on landing. Self weight of steps, that is 25 multiplied by 150 is 3.75 kilonewton per, sorry, 0.15 meter, that is 150 mm. So that is 3.75 kilonewton per meter square. Floor finish is, we are considering the floor finish thickness as 50 mm. So that is 0.05 multiplied by the unit weight of mortar, that is 20. So floor finish load is 1 kilonewton per meter square. Live load is 3 kilonewton per meter square. So total load on landing is 7.75 kilonewton per meter square. So we are considering this as a beam and we are finding the reaction at this support and this support. So here RA and RB. So total loads on going is 10.06 and total loads on landing is 7.75 kilonewton per meter square. So by taking moments about RA, we are getting RB as 16.05 kilonewton per meter and RA as 21.88 kilonewton per meter. So this load is coming on the this mid landing beam and this load is coming on the roof beam. So this is the way we have to apply the staircase load on the corresponding beams. The next is the live load. As we know that live loads are moving loads, we have to refer IS 875 part 2 for live load. For residential building, for all rooms and kitchen, 2 kilonewton per meter squared. For toilet and bathrooms, 2 kilonewton per meter squared. Corridor, passage and staircase, we have to consider 3 kilonewton per meter squared as live load. And for balconies also, we have to consider 3 kilonewton per meter squared. Next is the load combinations. So till now we have discussed how to calculate all the dead loads and live loads. So now we have to consider this load combination, so which is very important. For gravity loads, considering the 1.5 as a factor of safety, there are two load combinations, that is 1 into dead load plus live load, 1.5 times dead load plus live load. So these are the major two load combinations which we use for gravity loads. So friends, hope this video will be useful for you. If you find this video is useful, please post your comments and suggestions on the comment box.